guys, so on to the 4/4 problem at the bottom half of page 167 for lessons 4-2. So if you see the rules here, it basically goes over a lot of the things that we learned in the prior video. So the power of 0, which is if you put any number to the power of 0, it ends up being a 1. We talk about square root, which we know is a number times another number that fits in perfectly, ends up being a square root. For example, the square root of 4 is 2 because 2 times 2 equals 4. We talked about factorials, which means like you take a number and then you go down consecutively, like here, so 4, 3, 2, 1, and those numbers multiplied by one another give you an answer. And then it also says that you may use decimals, multiply, divide, subtract, and add. And what you have to do here is you're going to be given a list of numbers from 1 to 100. And you have to use 4 fours to create expressions for the values to end up getting the answers. And some problems may have many solutions, so your answer isn't necessarily going to be wrong if it's different than mine or someone else's. So let's check out how they have for 1. They have 4/4 plus 4 minus 4. So they check out with the 4 fours, but let's see how they got their answer. So there is 4/4 is 1 because any number over itself is just a whole number of 1. Then they added 4, so that'd get us to 5, and then they subtracted 4, which, hey, gets us to 1. Our next one is number 2, and how can we use 4 to get to 2? There's definitely a couple ways that we could do this. One way is you could do 4 power of 0 plus 4 power of 0, because that would just end up being 2. But you can't do that because, see, tricked you up here. Can't do that because there needs to be 4 fours. So what you have to do instead is something that you can use the 4 times. What this makes me think of is what they just did over here. It's kind of like a cheat to get an extra 4. You could do 4/4 plus 4/4, which would be, we know this is actually 1 because, like I said before, number over itself is a whole number, equals 2. You're going to do this for all of these numbers, which looks kind of intimidating, but once you get into a swing of it, it's not too bad. But let's go ahead and do a couple others together with a couple other kinds of examples so that you get the better hang of it. So I'm just going to pick a random one, and I'm going to pick, let's say, number 15. So once again, we are using 4 fours, and we want it to equal 15. The first thing that comes into my head is that 15 is very close to 16, and I know that 4 times 4 is 16, so I'm very close, and a lot of my options will help me get a 1. So if I ever need a 1, I could use, say, 4/4 to get that whole number, or I could use 4 to the power of 0, which will give me a whole number of 1 again. So what I'm going to do for this is I am going to, but I need 2 more 4s, so I'm going to use that to get my other 4 fours. So 4 times 4 equals 8, minus 4/4 is 15. So let's do one now where we can use a factorial. So let's look at 21. For number 21, I want to use a factorial so I can use a subtraction problem. So 4 factorial 4, so remember, I'm going to mess up my page a little bit. So that's 4 times 3 times 2 times 1. We already solved that for 24. So I'm going to have 24 here is what that represents. And I'm looking to get 21. So if this is 24 from 21, I know that this is going to be a subtraction problem. And I need 3 more 4s. And I need to subtract from this, from 24 minus 21. I need to get 3 out of this, so I need 3 1/4s. 3 4s that are equal to 1. So how I'm going to find that out is, let's see, I could subtract for number 21, 4, and then I would end up getting 20, because 24 minus 4 is 20. Then I need another 1, and this will, just a little, that'll give me my 4 4s. So 24 minus 4 plus 1, I have my 21. Let's do another one where maybe I could use a square root. So I'm going to look over here, and one that I think would be a good one to do is, let's do 34. So for number 34, which is right under a nice example here, I'm going to think, okay, I want to do 4 times 4. That right away is going to give me my 16. And then I'm going to multiply my 16, and I want to multiply it by 2, because 16 times 2 is 32. I can't just throw in a 2 though, because this is a game of 4s. But if I want a 2, I can throw in the square root of 4, because the square root of 4 is 2. So now I have 32. All I have to do is add an additional 2, and I get 34 times 4, which would be 16, with this other 2, with another 2, I get 34. So that's how you can use the power of 0, square roots, and factorials to solve for all these different numbers. So go ahead and go through this for 1 through 100 and see what you can come up with. Like I said, answers will definitely vary. And if you have any questions on the journal pages, please let us know.